All right, 28. So, oh, no, I need that. Okay, so 28 is a simple adding, subtracting a polynomial. So you guys probably did this before in Algebra 1. You can combine like terms, and so here you can see, though, that the only trick is that when you are subtracting an entire polynomial like this, you're going to have to distribute that negative sign to each. That is the only mistake that I usually see students do. And so as long as you take care of that and distribute this appropriately, just keep with the likes, okay? Keep the families with the families, and then you should get that answer there once you combine them. Now remember, when you're watching these, if you want to pause it so that you can kind of, if I'm going a little too fast, just pause it so you can clearly see the answer. I'm just going to try to shorten this video so at least you can get the answers. All right. Now here, when I multiply, though, you'll see that the parenthesis got clipped a little bit because I made a table. You could draw arrows, and you don't even have to draw arrows. You could do whatever you want, just as long as you make sure that if I have a binomial multiplied to a trinomial, I should get 6 terms, okay? Now, if I just do this as far as a multiplication cell, okay, you can see that I just rewrote these going vertically, and then I'll just make sure that I get all 6 of them very carefully, and then on the diagonally, I wouldn't even say, about 70% of the time, as long as these guys are in order and they go in descending, you're going to have like terms on the diagonals, okay? And then that's a great way to organize the entire string. And as long as I didn't make any mistakes here, we've got our first set. Now we're adding all the contents of this table now. You just add them. The multiplication is over, and you just go ahead and set them up, and that's it. That's your final answer. All right, so now when we go to number 30, now 30, what happened is they're asking for, is x minus 3 a factor of p of x, this polynomial, this cubic polynomial? If so, then write p of x as a product of 2 factors, okay? So if this guy goes in there evenly, I should have, as my final answer, 2 factors, okay? And one of them better be an x minus 3, right? Because if it goes in there evenly, my second factor will be over here. So let's go ahead and see if x minus 3 is a factor of this cubic. I put my coefficients in order. I don't have any zeros. Nope, I'm good. So I just go ahead and drop the 1, multiply 3 times 1, goes above the line, add. 3 times 4 is 12. Drop that down. That's a negative 5. 3 times negative 5 is negative 15. So that would be 0. So this is even. And so now my final answer is I have a 1, 4, negative 5. So this means, because that's a cubic, when I divide by a binomial, I'm actually of the first degree, then I drop it a degree, okay? So my final answer then would be 1, 4, negative 5. So 1 x squared plus 4x minus 5. Okay, that is the product of 2 factors. Now, if you have extra time and you're bored, you could multiply this out and see that you do get that. That's a way to check it, okay? All right, now this one is a sketch. Now sketch, you see sketch on this final exam, it really is just graphing on the graphic calculator. This guy's already preloaded, so I'm going to go ahead and do a zoom standard. Take a look at this guy. All right, and so it looks like I hit the x-axis at negative 3. So let's draw my own graph here. So negative 3. Negative 1, and 0. Okay, so it looks something like this. Okay. All right, but this is irrelevant. I can just go based off this. So on these intervals, as negative infinity goes to I actually don't know if you can see my cursor on the screen, so I'm actually going to just use my fingers here. You can see from negative infinity to negative 3, it actually stops at the x-axis. So my guess is that from here to there, I know that one of the terms I know is whether or not something is a negative interval. And that is definitely a negative interval. So let's see if this checks out. From negative 1 to 0, negative 1 to 0, yes. Okay, so this is actually the negative interval, and I'm just going to abbreviate that. Okay. And then from negative infinity to negative 2. So negative infinity to negative 2, it looks like this guy is negative and positive, but I know that my other pair of possible interval descriptions is whether or not something is increasing or decreasing. So I know from here to here I'm actually increasing, okay? So this means I better increase also from, I don't know, what is that, -1/2 to positive infinity, and that's exactly what I have here. So this guy is increasing. So I'm going to use the opposites of these and these two for sure. What am I doing from -3 to -1? -3 to -1. That looks like the part that's above the x-axis because I'm both increasing and decreasing on that interval, so I can't be that. This is clearly positive, so if I went from 0 to infinity, am I positive? And the answer is yes. Okay, so this is a positive interval. And then f is what? Let's see. Well, from -2 to -1/2, that clearly is decreasing. Okay, so that's my answer for 31. And then finally, for 32, we're at the 5-minute mark. Great. Okay, I'm going to actually write this on the sheet of paper here. I've got 64. Now, this is actually from your grid work homework. That worksheet actually is kind of really valuable because those are like the hardest ones you can do. So, and you did so many of them on that homework that, you know, you might see the same thing show up again. You might have already done it. I've probably already done this in my past many times through the years. So not just in teaching, but like in previous studies in college. So what I'm looking for is whether or not it's a square or a cubic binomial. Okay, and this is cubic because I see that I have a variable raised to the third power. Now sometimes it's a little trickier because this guy is a perfect square, but he's also a perfect cube. 27 is not a perfect square, but he is a perfect cube. So I'm going to treat this one as a perfect cube rather than the possible perfect square. Because this guy's a perfect cube, I need something that lines up like this. Okay, now notice I am using the sum. So I'm going to use the sum of two cubes rule. So what I do is I figure out, well, what has to be my A, what has to be my B. Okay, my A and my B are basically my first and second terms respectively. So 64 is actually 4 to the third power. So I'm just going to write 4. I'm not going to keep that in my head. I'm going to actually write it down. So when I do my formula, it is very straight to the point. Okay, no ambiguity. This one here, what raised to the third power? Well, it's got to be 3. And obviously the A is going to be raised to the third power. Now, hopefully on your note card, you have written the formula that the sum of two cubes has to be this. A plus B, and then you have A squared minus AB plus B squared. That is the formula. It's just something that hopefully, well, by the end of your pre-calc year, you'll definitely have it memorized. Okay. So my first couple years teaching, I had to like look it up every year because, you know, it would escape me. But, you know, the pattern just kind of sticks eventually. And so what I will do is I will just follow this pattern. I know what my A is. I know what my B is. So I literally just substitute. Okay, my A for my B. I'm sorry, my A for my A, B for my B. And now I'm going to go A squared. That's going to be 16 now. Okay, 4 is my A, so A squared, minus A times B. So A times B is 12A minus 12A. And then 3A is going to be squared. So that would be plus 9A squared, not 3A squared. Okay, make sure you square the 3 as well. And this guy are done. These guys are unfactorable. There's nowhere else for you to go. Sometimes on these properties, like when we did, if you look at the very last problem, what was that, 30 something, sometimes you can do the difference of two squares and you can keep going. You cannot keep going with the difference or sum of two cubes. They're basically locked in place. And the only reason that this is helpful is later on in higher up math, this guy can actually factor out for more convenient issues. All right, but that's down the road, and that's it. Good luck, everybody. I hope you use your note card wisely, and I will see you tomorrow.